topic of our video is mineralogy. So, before we proceed in mineralogy, let us first define the definition of mineral and have a short briefing about it. We use minerals every day, whether within those vitamin supplements we take, or an essential item like fertilizer, cement, rubber, or practically anything, because they are important to our everyday life, because they are the building blocks of rocks, which are everywhere. And we will get more to the practical uses of rocks and minerals. So, what is exactly the mineral? There are 5 basic requirements that an object must meet to be classified as a mineral. It must be naturally occurring. That means it can't be made in a laboratory. Man-made things like plastic does not count as a mineral. It has to be inorganic. It can't be produced by an animal or plant or be made out of living things. Coal, which is made of compressed skeletons of ancient plants, would not be classified as a mineral. It has to be solid. Liquids and gases are not minerals, so the helium gas in a balloon isn't a mineral. It's an element. It has to be a definite chemical composition. If the minerals are the building blocks of rocks, elements are the building blocks of minerals. A definite chemical composition means that each of the differently classified minerals is made of particular elements in particular proportion that are always the same for that mineral. This just means that different minerals have different chemical formulas, like molecules. The last is ordered atomic arrangement. This means that the atoms making up the mineral must be arranged in a specific way to be classified as that mineral. This also means that 2 different minerals can be made in the same element, just arranged differently. For example, graphite and diamond, both made of elements, are both made of only carbon, and the only difference between them is that how that carbon are arranged. Sheets for graphite and tetrahedral form for diamond. So those are the 5 requirements of a mineral. So now let's proceed to our chosen topic, which is mineralogy. Mineralogy is a branch of geology concerned with the study of all aspects of minerals. Mineralogy is specializing in the scientific study of chemistry, crystal structure, and physical properties of minerals, and mineralized artifacts. Ibig sabihin, mapag-aaralan natin dito about sa minerals, their crystallography, yung properties nito at classification, at yung mga paraan kung paano natin madidistinguish o matutuko yung iba't ibang klase ng mineral. So now I am going to discuss the first subtopic under the mineralogy, which is elementary knowledge on symmetry or crystallographic system. So let's get started. But the first question is, why do we need to study crystallography? Crystallography is useful for the identification of minerals. It is also the study of crystals that can provide new chemical information. Also, crystallography is of major importance to a wide range of scientific disciplines, including physics, chemistry, molecular biology, and the material science and mineralogy. It is also very useful for solid-state studies of minerals. It is also important in crystal heating therapy. So what is crystallography? Crystallography is simply a fancy word meaning the study of crystal. It is the study of crystalline solid and principles that govern their growth, external shape, and internal structure. Crystallography is easily divided into 3 sections, which is geometrical, chemical, and physical. So here are some trivia about crystallography. Do you know that crystallography is the experimental science of arrangement of atoms in solids? In fact, the word crystallography derives from the Greek words kristallon, which means cold drop or frozen drop, with its meaning extending to all solids with some degree of transparency, and the grapho means right. So if crystallography is the study of crystals, what is the definition of the crystal? A crystal is a regular polyhedral form bounded by the smooth faces, which is assumed by a chemical compound due to the action of its interatomic forces when passing under suitable conditions from or gas to that of a solid. After knowing the definition of crystallography, let's move on to the unit cell. The unit cell of a mineral is the smallest divisible unit of mineral that possesses all the symmetry and properties of the mineral. It is a small group of atoms arranged in a box with parallel sides that is repeated in 3-dimension to fill space. It has 3 principal axes, which is A, B, and C, and 3 interaction angles, which is alpha, beta, and gamma. 3 unit cells vectors are A, B, C, 3 angles between vectors alpha, beta, gamma. Alpha is angle between B or C, and beta is an angle between A and C, and gamma is an angle between A and B. Now let's proceed to crystal systems. The 7 crystal systems are a method of classifying crystals according to their atomic lattice or structure. Atomic lattice is a 3-dimensional network of atoms that are arranged in a symmetrical pattern. The shape of a lattice determines not only which crystal system the sun belongs to, but all of the physical properties and appearance. There are 7 crystal systems or groups, each of which has a distinct atomic lattice, and these are cubic, tetragonal, trigonal, orthorhombic, monoclinic, hexagonal, and triclinic systems. So the first crystal system is the cubic crystal system, also known as the isometric system. The cubic crystal system is characterized by its total symmetry. The cubic system has 3 crystallographic axes that are all perpendicular to each other and equal in length. The cubic system has 1 lattice point on each other of the cube's 4 corners. So the second is rhombohedron. It is also known as trigonal system. It is the 3 crystallographic axes that are equal in length and intersect at right angles to each other. It has 3-dimensional shape that is similar to a cube, but it has been skewed or inclined to one side for making it oblique. So the third one is tetragonal crystal systems. It has 3 axes, all at right angles, 2 of which are equal length and 1 of which is different in length. Tetragonal crystal is a simple cubic shape that is stretched along its axis to perform a rectangular prism. The tetragonal crystal will have a square base and top, but a height which is taller. By continuing to stretch the body-centered cubic, one of the Bravais lattice of the tetragonal system is constructed. Orthorhombic crystal system has 3 axes, all at right angles, and 3 of different lengths. Minerals that form in the orthorhombic, also known as rhombic, crystal system have 3 mutually perpendicular axes, all with different or unequal lengths. Hexagonal crystal system. It has 4 crystallographic axes. 3 of the axes fall on the same plane and intersect at the axial cross at 120 degrees between the positive ends. These 3 axes are the same length, and the 4th axis is different in length. Crystals that form in a monoclinic system have 3 unequal axes. The A and C crystallographic axes are inclined toward each other and an oblique angle, and the B axis is perpendicular to A and C. The B crystallographic axis is called the orthoaxis. The 3rd axis is perpendicular to the other 2 axes. Triclinic system. The 3 axes are all unequal in length and intersect at 3 different angles. Triclinic crystals have 1/4 symmetry axis with virtually no discernible symmetry and no mirrored or prismatic plates. As you can see, these are examples of crystal systems.
I'm Axel Caluag and I'm going to discuss the definition of symmetry. Symmetry is the set of mathematical rules that describe the shape of an object. Infinite lanes of symmetry pass through its center. Infinite rotational axes are present, and no matter how little or how much you rotate it on any of its infinite number of axes, it appears the same. So, here are some trivia about symmetry. Do you know that there is only one object in the symmetrical universe with perfect symmetry? And that the answer in that is no other than sphere. Symmetry is the consistency, the repetition of something in space or in time, especially infinite objects. There are a number of operations describing repetition and are called elements of symmetry. Point of symmetry. It is macroscopically visible symmetry operation. After it has been applied to crystal, at least one point remains where it was. There are planes of symmetry, rotation of axis of symmetry, center of symmetry, and roto-inversion. First is the planes of symmetries. It is any two-dimensional surface that, when passed through the center of the crystal, divides it into two symmetrical parts that are mirror images. It is reflection symmetry in two directions. It is simply like the concept of mirror where the image is found perpendicular to reflection plane and equidistant from the plane on the opposite side of the plane. So the next is the axis of symmetries. It is an imaginary line through the center of crystal around which the crystal may be rotated so that after a definite angular revolution, the crystal forms appears the same as before, depending on the amount of degrees of rotation necessary. So, 4 types of axes of symmetry are possible when you are considering crystallography. There are 4 types of axes of symmetry. The first one is the binary symmetry, when the rotation repeats every 180 degrees, and the second is trigonal symmetry, when the rotation repeats form every 120 degrees, and the third one is tetragonal symmetry, when the rotation repeats form every 90 degrees, and lastly is the hexagonal symmetry, when the rotation repeats form every 60 degrees. Center of symmetry. Most crystals have a center of symmetry even though they may not possess either planes of symmetry or axes of symmetry. Triclinic crystals usually only have a center of symmetry if you can pass an imaginary line from the surface of crystal face through the center of the crystal axial cross and intersects a similar point on the face equidistant from the center, then the crystal has a center symmetry. The last is the roto-inversion. The object will be transformed into itself after the following 2-step operation. Example is the 4-fold roto-inversion, a rotation of 90 degrees along the axis, followed by the inversion with respect to a point on the axis.
Good day, my name is Sharlin P. Dandan from BSCE 2C. And I'm here to present to you the physical properties of minerals. Physical properties of minerals used by mineralogists to help determine the identity of minerals. We have here the important physical properties of minerals that we can use to identify a mineral. We have color, streak, cluster, structure, hardness, specific gravity, cleavage, fracture, tenacity, and form. Color. Color is one of the most obvious properties of a mineral. Color should be considered when identifying a mineral, but should never be used as the major identifying characteristic. But color is not reliable when identifying some minerals because some minerals can occur in a variety of different colors due to the impurities in the mineral, just like quartz. Quartz can be in a color of white, clear, gray, brown, yellow, orange, or pink. Next is streak. Streak is the color of the minerals in powdered form, which is more useful for identifying the color of a whole mineral sample. Dito sa streak, we will use streak plate where we can scratch the mineral to identify the color. Meron dong kapag in-scratch mo dun yung minerals, tapos lalabas na dun yung pinaka-powdered form niya. doon na natin ma-identify kung anong kulay nga ba yung minerals. This is a straight plates. Dito, i-scratch yung minerals para malaman kung anong color nga ba siya. Next, luster. Luster is the general appearance of a mineral surface in reflected light. There are important terms used to denote the luster of minerals: metallic, non-metallic, classy, or virtuous, and pearly luster. Dito sa luster, we can identify a minerals pagka nag-reflect yung light or kaya pagka merong tumatamang ilaw sa may mineral mismo. Malalaman natin kung glassy ba siya, metallic, or parang pearl, parang makinang, ganon. Here are the examples of metallic, non-metallic, and pearly luster. Makikita natin dito sa may metallic luster, as in parang metallic talaga yung physical appearance niya. Dito naman sa non-metallic, it's like a dull, clay-like, or kaya earthy. Dito naman sa pearly, look like pearls, shiny, basta yung makinang na parang pearl. Next is structure. It's a term used to denote the shape and form of a mineral. These are the important terms used to denote the structures of minerals: columnar, bladed, radiated, lamellar, botryoidal, and geniform structure. Columnar structures, the mineral has a thick or thin column-like structure. In the blade structure, the mineral has a blade-like structure. Radiated structure, for columnar of fibrous diverging from central points. Lamellar structure, the mineral made of separable plates. Botryoidal structure, for an aggregate-like bunch of grapes. Reniform structure, for kidney-shaped aggregate. Next is hardness, the resistance that a smooth surface of a mineral offers to scratching, and there is a scale that is used to measure the hardness of a mineral, known as Mohs scale of hardness. And here is the Mohs scale of hardness. As you can see, diamond is the most hard mineral, while the talc is the least hard mineral in this table. Next is specific gravity. It may be defined as the density of the mineral compared to the density of water, and as such represent a ratio. Specific gravity of a mineral is the ratio of its weight of an equal volume of water. Specific gravity of minerals depends upon the weight and spacing of its atom. All minerals have density. Densities that are high or low may be easier to identify the mineral. Non-metallic minerals have low densities, while metallic minerals have high densities. Cleavage. It is defined as the tendency of a crystallized mineral break along center definite planes, yielding more or less smooth surfaces. Cleavage is related to the internal structure of a mineral. The cleavage planes are always parallel to some faces of the crystal form of typical mineral. It is also described on the basis of perfection or the degree of easiness, which means minerals can split along the cleavage planes. Fracture. It may be defined as the appearance of broken surfaces of a mineral. If the mineral contains no planes of thickness, it will break along random directions called fracture. These are the common types of fracture. Conchoidal fracture, the broken surfaces of concentric rings or curved surface. This is a conchoidal. Yung conchoidal term is described as the smooth curve that resembles an interior of shell. Ganon. Parang shell siya na naka-curve. Ganon yung itsura ng conchoidal. Even fracture, when the broken surface is smooth and flat. Dito naman sa even fracture, yung minerals is as in flat siya na makinis, yung hindi bako-bako. Uneven fracture, when the mineral breaks with an irregular surface. It is a common fracture of many minerals. Ito naman yung kabaliktaran ng even fracture. Diba, sa may even, as in patag, smooth lang yung minerals, yung texture ng minerals. Dito sa uneven, hindi. Splintery fracture, when minerals break with the rock. Dito sa splintery fracture is like a fibrous or finely needle-like shape. Parang may hibla-hibla siya, ganun. These minerals are the examples of cleavage and fracture. Tenacity. It refers to a mineral's resistance to breaking or being deformed. Dito sa may tenacity, example niya na mineral niya is calcite or fluorite. Calcite and fluorite are brittle. Kapag natamaan sila or na-hit, yung madali silang ma-break or masira. Important properties related to tenacity of the minerals are expressed by the terms like balances, flexibility, sectility, and malleability. Sectility, if minerals can cut with knives, but slices are not malleable. In flexibility, minerals can be bent. And lastly, in malleability, if the minerals can be flattened by the pounding with a hammer, it is malleable. And lastly, form. Form, also known as the crystal form, refers to the geometric shape of mineral crystals. Crystal form is caused by the symmetrical three-dimensional arrangement of atoms inside the mineral. We have here a cubic-like mineral, prismatic, and amorphous. And this is the end of my report. I hope I explained the topic clearly. Thank you.
Good day everyone. I'm Kevin Joshua Aguila from BSc 2C, and I'm here to present to you the study of rock-forming minerals. Rock-forming minerals. Any minerals that form igneous, sedimentary, or metamorphic rocks and that typically or solely form as intimate rock-making processes. Ang kahit na anong mineral na nabubuong igneous, sedimentary, or metamorphic rocks ay madalas na nangyayari sa magkakaliit na parte ng bato. At ang rock-forming minerals ay importante at ito ay nakakatulong sa atin upang makadevelop ng new technologies at ginagamit din itong rock and minerals para sa building materials, cosmetics, cars, and appliances. At mayroon tayong kulang 5,000 species ng minerals sa buong mundo. To be considered a common rock-forming mineral, a mineral must be one of the most abundant mineral in earth crust, be one of the original mineral present at time of a crustal rocks formation, be one of important mineral in determining rock classifications. And here the rock-forming minerals are feldspar, quartz, amphibole, mica, olivine, garnet, calcite, pyroxene, chlorite, serpentine, staurolite, epidote, and zeolite. Feldspar. Feldspar, they are the most common mineral in earth crust. They are often white, cream pink, and may form crystal that look small blocks. They usually have smooth, glassy, or pearly luster. Feldspar is common raw material used in glass making, ceramic, to some extent a filler extension in paid plastic and rubber. feldspar ang karaniwang makikita sa labas ng bahagi ng mundo. Ang karaniwang kulay nito ay white cream pink, kadalasan ito ay makinis at makintab o kaya ay parang pearlescent na malambot. Ang feldspar ay karaniwang ginagamit sa paggawa ng salamin o ceramics at mandagdag sa materyales sa mga pintura, plastic at goma. Quartz. It consists 1 part silicon and 2 parts of oxygen. This is the most abundant mineral found at the Earth's surface. It is clear or white color. It also has birch's luster. Quartz crystals are used to make oscillators for clocks and electronic gadgets. Yung quartz naman ay maraming matatagpuan sa ibabaw ng mundo. Ito ay malinaw o puti ang kulay. Ang quartz crystal ay ginagamit sa paggawa ng oscillator ng relo at electronic gadgets. Amphibole. Amphibole are complex hydrosilicate containing calcium, magnesium, and iron. They can be black, dark brown, green, or blue. It is also used as crushed stone for the usual crushed stone applications such as road and railroad bed construction. Amphibole ay mayroong hydrosilicate na nagtataglay ng calcium, magnesium at iron. Kadalasang kulay nito ay dark brown, black, green, and blue. At karaniwang ginagamit ito sa mga kalsada at bed ng mga railroad. Mica. Mica is mineral name given to group of minerals that are physically and chemically similar. Micas are very light and relatively soft, and sheets and flakes of mica are flexible. Mica are used in electrical insulator and electronic equipment. Mica ang pangalan na binigay sa grupo ng mga mineral na magkakamukha ang hugis at chemical. Ang mica ay magaan at ito ay flexible. Ginagamit ang mica sa mga electrical insulator sa mga electronic equipments. Next is olivine. It is the most common member of group silicates. Colored birch's shade of green luster, glassy, transparent to translucent. It is found igneous rock that are rich in magnesium and low quartz. Most olive used in metallurgical processes as a slag conditioner. Ang olivine ay ang pangkaraniwan na membro ng group of silicates. Ang kulay nito ay green at malinaw na parang salamin. At kadalasan itong ginagamit sa metallurgical process bilang slag conditioner. Garnet. Garnet are better known as gem than a forming minerals. Garnet is very hard mineral that can be red, brown, yellow, or green, but most commonly red-brown in color. Chemically, garnet contain the elements calcium, magnesium, iron, and aluminum combined with silicon and oxygen. Garnet is usually thought of as gemstone, but most garnet is mined by industrial uses. Garnet ay kilala bilang gem o mamahaling bato. Kaysa sa batong namuong mineral, ito ay matigas at pwedeng pula, brown, dilaw o green. Ngunit ang pangkaraniwang kulay nito ay red-brown. Ito ay karaniwang inaakala na mamahaling bato, pero pangkaraniwan ang garnet ito ay binimina para sa pangkalahatang gamit. Calcite. Calcite is a rock-forming mineral with chemical formula of calcium carbonate. It is extremely common and found throughout the world in sedimentary, metamorphic, and igneous rock. Calcite crystal properties make it one of the most widely used minerals. It is used in building materials, abrasive, agricultural, soil treatment, construction, aggregate, pigment, pharmaceutical, and other application. Itong bato na ito ay nabuong mineral na may chemical formula ng calcium carbonate at matatagpuan ito sa lahat ng parte ng mundo, sa mga sedimentary, metamorphic, at igneous rocks. Ginagamit ang calcite sa maraming bagay, sa materialis ng building, abrasive, soil treatment, construction, pharmaceutical at iba pang bagay. pyroxene. Pyroxene are complex silicate closely related to the amphiboles. Pyroxene are often found as primary mineral in igneous rock. They too are often fibrous or needle-like moss, are gray or green-gray, grading to black. A few pyroxene minerals are used as gem materials, but only in rare instances when they have attractive color and clarity. Ito ay complex silicate na malapit sa amphibole. Ito ay madalas natatagpuan. Ito ang pangunahing mineral sa igneous rock. Madalas ito ay bukol-bukol o tusok-tusok. Madalas ito ay kulay black, gray at green. Chlorite. Chlorite is the name of group of common shaped silicate mineral that formed during the early stage of metamorphism. Most chlorite minerals are green in color, have foliated appearance. They are found in igneous metamorphic and sedimentary rocks. Chlorite are disinfection byproduct resulting from the use of chlorite dioxide as a disinfectant and for odor, taste control in wastewater. Chlorite ang tawag sa mga minerals na nabubuo sa unang stage ng metamorphism. Karaniwan sa chlorite mineral ay green o foliated ang itsura. Ang chlorite ay panglinis at pang-disinfect, pang-alis sa lasa ng tubig. Serpentine. Serpentine is a group of mineral that are usually green in color. The mineral serpentine is secondary mineral which also occurred metamorphosed serpentine rocks. It is used as gemstone, architectural stone, curving material, and source of asbestos. Serpentine. Ito ay grupo ng mineral na karaniwang kulay green at ito ang secondary mineral na nabubuo bilang metamorphosed serpentine rocks. Ito ay ginagamit gemstone, architectural stone, at carving materials, at pinanggagalingan din ng asbestos. Staurolite. Staurolite is iron aluminum silicate often found with garnet in such metamorphic rocks. It's usually brown or black in color with residues to virtuous luster. Staurolite almost always occur in crystal as automorphic prism and commonly as twin crystal. It is used in geologic field work to assess the temperature, pressure, condition of rock metamorphic history. Staurolite, ito ay iron aluminum silicate na natatagpuan kasama ng garnet sa mga metamorphic rocks. Ito ay karaniwang brown or black ang kulay. Ito ay ginagamit sa geologic field work bilang pang-assess sa temperature, pressure, condition ng rock metamorphic history. Epidote. Epidote is one of the group complex silicate of calcium of aluminum with water. It is formed nearly type of metamorphic rocks. Epidote color varies from green to brown and black. It can be easily identified by hardness and color. Epidote has no significant use in industrial mineral, has only minor use as a gemstone. Epidote. Ito ay grupo ng mga complex silicate, calcium at aluminum na may tubig, kadalasang nabubuo sa kahit anong klase ng metamorphic rocks. Ang kulay nito ay green, brown, or itim. Ito ay madaling makilala sa tigas at kulay na to. Ito ay hindi ginagamit sa industrial material at mababang uri lamang ng gemstone. And the last is zeolite. Zeolite are not major rock former but they are widely distributed. Their name means boiling stone. Zeolite, their associates are often found in lavas, filling cavities, and veins. Based on the pore size and absorption property, zeolites are among the most important organic cation exchanger and are used in industrial application for water and wastewater treatment. Hindi gaanong mahalaga na bato ito at matatagpuan sa mga lava based sa pore size at absorption properties. Ang zeolite ay importanteng organic cation exchangers at ginagamit itong industrial application sa tubig upang linisin ang mga tubig. And that's all. Thank you.
Good day everyone, my name is Cloyd Callos from BSc E2C, and today I will discuss these few types of minerals. First, quartz family. It is an important rock-forming mineral next to feldspar. Next, it is a non-metallic refractory mineral and it is a silicate group. So sabi dito, ito ay isang mahalagang mineral na bumubuo ng bato kasunod ng feldspar. Next, ibig sabihin daw nito ay isa daw siya sa mga mineral na mayroong resistance sa matataas na temperature or tinatawag na high melting points. Last one is kabilang daw siya sa mga silicate group, which is yung mga mineral na nagko-contain ng elements na silicon at oxygen. Physical properties of quartz. Crystal system, so ito yung kanyang shape na hexagonal. Habit, crystalline or amorphous, which means kumikinang or yung meron siyang glass forming ability. Fracture, conchoidal. So, ibig sabihin ng fracture is kapag ito daw ay nabiyak or nasira, magkakaroon siya ng conchoidal shape or smooth rounded surface. Next, transparency. So, yung quartz daw ay pwedeng transparent, semi-transparent, at opaque. So, yung opaque daw is yung kabaliktaran ng transparent. Next is colored varieties. So, yung pure quartz is colorless and transparent. Gaya ng nasa picture, amethyst, pure purple or violet, smoky quartz, shades of gray, milky quartz, light brown or pure white, and the last one is rose quartz, which is color pink or rose. Uses of quartz. Geological processes have occasionally deposited sands which are composed of virtually 100% quartz grains. These deposits have been identified and produced as a source of excessive purity silica sand. These sands are used within the glass-making enterprise. Quartz sand is used inside the production of field glass, flat plate glass, uniqueness glass, and fiberglass. So, ginagamit daw yung quartz sa so yung quartz daw is source of excessive purity silica sand. So, yung sand daw na to ay ginagamit sa paggawa ng mga glass or mga fiberglass, glass plate, gaya ng mga nasa example. Next is feldspar family or group. It is most abundant of all minerals. It is used for making more than 50% by weight crust of earth. And it is non-metallic and silicate minerals. So, ito daw yung may pinakamarami sa lahat ng minerals, or ito daw yung pinaka-common. Next, ito daw yung nagbibigay ng 50% na bigat sa ating Earth's crust. And kabilang din daw siya sa non-metallic at silicate minerals. Physical properties of feldspar. Crystal system, or yung shape niya, monoclinic or triclinic. So, ibig sabihin nito, hindi daw siya magkakapantay. Habit, tabular. So, which means para siyang mga tabla. And cleavage. So, yung cleavage is kapag nabiyak daw siya is perfect or two-directional. And transparency, which is really transparent. So, bihira lang daw yung transparent na feldspar. Next. Chemical composition. Potash feldspar. Potash feldspar are often not as pure and white as soda spars. A feldspar is typically referred to as potash if there is significantly more potassium than sodium, and if the amounts are closer to equal, they are termed potash soda feldspar or vice versa. So, ang ibig sabihin nito, ang mga potash feldspar ay kadalasang hindi kasing dalisay or hindi kasing pure gaya ng mga soda spar. Ang feldspar ay karaniwang tinutukoy bilang potash, which means na mas higit yung potassium kaysa sa sodium, at kabaliktaran naman nito ang potash soda feldspar kung mas madami ang sodium kaysa sa potassium. Uses of feldspar. Feldspar is a common uncooked fabric utilized in glassmaking, ceramics, and to a point as a filler and extender in paint, plastics, and rubber. In glassmaking, alumina from feldspar improves product hardness, sturdiness, and resistance to chemical erosion. So, ibig sabihin nito, ang feldspar ay isang pangkaraniwang element na ginagamit sa paggawa ng salamin, ceramics, at pwede ring idagdag sa panggawa ng pintura, plastics, at goma. So, sa paggawa daw ng salamin, nakatutulong daw yung feldspar sa pagpapatibay ng mga produkto at nakakatulong din ito na panglaban sa mga kemikal. Next is augite. Augite is named after the Greek word augites, which means brightness. It belongs to the pyroxene group, and it is the most common. It is a common constituent of lunar basalts and some meteorites. So, ibig sabihin nito, yung augite daw is galing sa Greek word na augites, na ang ibig sabihin ay brightness. Next, ito daw ay kabilang sa pyroxene group, at ito daw yung isa sa pinaka-common or madami. Next is isa ito sa mga nabubuong elements mula sa mga meteorites at iba pang mga bagay na matatagpuan sa buwan. Next, physical properties of augite. Colors: brown-green, green-black, brown, purplish-brown. And yung crystal system nito ay monoclinic, which means hindi pantay gaya ng sa feldspar, fractures, irregular, or uneven. So, yung kagaya ng kanina, kapag daw nabiyak yung augite ay hindi daw siya pantay, and yung transparency is opaque. So, ibig sabihin, hindi siya transparent. Uses of augite. Augite is a mineral of interest to geologists and collectors. While it has little to no industrial value, the presence and development of augite may help tell scientists and geologists about Earth's history in certain regions. So, sabi dito, yung augite daw ay wala masyadong industrial value or hindi pwedeng gawing materials. Pero para sa mga geologists at collectors at scientists, ito daw ay makatutulong sa pag-aaral ng Earth's history sa ibang panig ng mundo. Last is hornblende. Is a inosilicated amphibole minerals. And the name hornblende is applied to a group of minerals that can be distinguished from each other only by detailed chemical analysis. The word it is derived from the German horn and blenden, which means to deceive, in allusion to its similarity in appearance to metal bearing or mineral. So, first, ito daw yung mineral na nagtataglay ng silicon oxygen na bumubuo na parang kadena. Yun daw yung ibig sabihin ng inosilicate. Isa daw siya sa pangkat ng mga mineral na maaaring makilala ang bawat isa sa pamamagitan ng detalyadong pagsusuri ng bawat chemical. And last is, galing daw yung salitang hornblende sa salitang German na horn at blenden, na ang ibig sabihin ay manlin lang or to deceive, dahil kapareho daw ito ng mga mineral na ginagawang metal or metal bearing minerals. Next is physical properties of hornblende. Colors: dark green, usually black, dark brown. So ito daw yung mga karaniwang kulay ng hornblende. And yung crystal system, which is monoclinic. So kagaya nung kanina, yung shape daw ng hornblende is hindi pantay, and transparency, opaque. So ibig sabihin hindi daw siya transparent. Cleavage, two directions, which means kapag daw nabiyak or nasira yung hornblende, hindi daw basag-basag or mahahati lang sa dalawa. And uses of hornblende: first, crushed and used as road constructions and railway ballast. So ibig sabihin nito, yung ginagamit daw yung hornblende sa paggawa ng mga road, or ito daw yung mga nakalagay sa paligid ng ating riles or railways. Next is, it was cut to be used as a dimension stone. So ginagamit daw to bilang dimension stone or parang panghati sa bakuran, ganun. And last is, the highest quality pieces are cut, polished, and sold under the name black granite, or used as a building facades, floor tiles, countertops, and other architectural uses. So yung hornblende daw, yung mga highest quality or yung mga pinakamagagandang piraso ay binebenta or tinatawag na black granite, at ginagamit daw ito bilang pang-design sa mga bahay or sa building, at pwede rin daw itong gamiting floor tiles or countertops. That's all, and thank you.
What is biotite? Biotite is a name used for a large group of black mica minerals that are commonly found in igneous and metamorphic rocks. The name biotite is used in the field and entry-level geology courses because these mud minerals generally cannot be distinguished without optical, chemical, or X-ray analysis. Biotite is a rock-forming mineral found in a wide range of crystalline igneous rocks such as granite, diorite, gabbro, peridotite, and pegmatite. It also forms under metamorphic conditions when argillaceous rocks are exposed to heat and pressure to form schist and gneiss. Although biotite is not very resistant to weathering and transforms into clay minerals, it is sometimes found in sediments and sandstones. Muscovite. Muscovite is the most common mineral of the mica family. It is an important rock-forming mineral present in igneous, metamorphic, and sedimentary rocks. Like other micas, it readily cleaves into thin, transparent sheets. Muscovite sheets have a pretty to vitreous luster on their surface. If they are already held up to the light, they are transparent and nearly colorless, but must have a slight brown, yellow, green, or rose-colored tint. The ability of muscovite to split into thin, transparent sheets, sometimes up to several feet across, gave it an early use as window panes. In the 1700s, it was mined for this use from pegmatites in the area around Moscow, Russia. These panes called are Muscovite glass, and the term is thought to have inspired the mineral name muscovite. Calcite. Calcite is a rock-forming mineral with the chemical formula of CaCO3. It is extremely common and found throughout the world in sedimentary, metamorphic, and igneous rocks. Some geologists consider it to be a ubiquitous mineral, one that is found everywhere. Calcite is a principal constituent of limestone and marble. These rocks are extremely common and make up a significant portion of Earth's crust. They serve as one of the largest carbon repositories in our planet. Garnet is the name used for a large group of rock-forming minerals. These minerals are found throughout the world in metamorphic igneous and sedimentary rocks. Most garnet found near Earth's surface forms when a sedimentary rock with a high aluminum content, such as shale, is subjected to heat and pressure intense enough to produce schist and gneiss. Garnet is also found in the rock of contact metamorphosis, subsurface, magma chambers, lava flows, and deep surface. Most people associate the word garnet with the red gemstone. However, they are often surprised to learn that garnet occurs in many colors and has many other uses. In the United States, the major industrial uses of garnet in 2012 were water jet cutting, abrasive blasting media, water filtration granules, and abrasive powders.
Good day everyone! I'm Lester King Gelardo from VSC 2C, and I'm going to discuss about the formation of minerals. To form a mineral crystal, the elements required must be present in the proper proportions. The physical and chemical condition must be favorable, and there must be enough time for the atoms to arrange themselves. Physical and chemical conditions include factors such as temperature, pressure, presence of water, pH, and the amount of oxygen available. Time is one of the most important factors because it takes time for atoms to become ordered. If time is limited, the mineral grains will remain very small. The presence of water enhances the mobility of ions and can lead to the formation of larger crystals over shorter time periods. Minerals can be formed in several ways. First, crystallization from magma. The majority of the minerals in the rock around us form as a result of the cooling of molten rock, known as magma. Some geological materials are liquid at the high temperatures found deep within the earth. Magma cools and minerals crystallize as it rises through the crust, either through volcanic eruption or through more gradual processes. Next is by sublimation. Sublimation is a chemical process in which matter changes from a solid to a gas without passing through the liquid phase. When superheated, mineral-rich gases escape from deep subsurface chambers. They reach the surface via fumaroles, vents, and volcanoes. Minerals form around hydrothermal and volcanic openings due to extremely rapid temperature and pressure drops. Minerals that can be formed through sublimation include sulfur and cristobalite. Third, by precipitation from aqueous solution. Solutions are made of ions or molecules known as solutes that have been dissolved in a medium or solvent. Water is the most common solvent found in nature. Many minerals can be dissolved in water such as halite or table salt. The size and texture of the crystals formed depends on the rate of change in temperature and pressure, which essentially determines how much time is available for the crystals to develop. It can be precipitate in two ways. First, minerals from salt water. When seawater evaporates, a solid precipitate of minerals is left behind. The amount of dissolved minerals and salts that can be held in water is limited. When the concentration is too high to remain dissolved in water, the particles merge to form mineral solid, which sinks. Second, minerals from hot underground water. Magma hits nearby underground water, causing it to react with the rock around it, collecting dissolved particles. As water cools and flows through open spaces in the rocks, solid minerals are deposited. Veins are minerals deposits that form when a mineral fills cracks in rock. Large crystals form when minerals are deposited in open areas. Next process is metamorphism. When pre-existing rocks are exposed to high temperatures and pressures beneath the Earth's surface, metamorphic rocks form. Some pre-existing minerals transform into new minerals when exposed to higher temperatures and pressures. Others recrystallize and expand in size. Another process is chemical weathering. When minerals react with air and water, they weather chemically. Some minerals dissolve in these processes, while others combine with atmospheric elements, primarily water, oxygen, and carbon dioxide, to form new minerals. As you can see in the figure, the left photo is the unweathered one, and in the right is the product of chemical weathering. On the unweathered surfaces, the feldspars are still fresh and glassy looking. On the weathered surface, the feldspar has been altered to the chalky looking clay mineral kaolinite. In summary, minerals form as magma or lava cools, when they precipitate from hot fluids that have cooled down, from dissolved substances when water evaporates, and lastly, from pre-existing minerals. And that is the end of my report. Thank you for listening.
Good day everyone, I'm Gia Ashley C. Jose from BSCE 2C, and for today I will present you the basic informations about coal and petroleum. Coal and petroleum are formed as a result of degradation of ancient plant life which lived millions of years ago. This dead plant matter started to pile up, eventually forming a substance called peat. Over time, heat and pressure from geological process transform these materials into coal. Since these are formed from essentially fossils, they are also known as fossil fuels. How is coal formed? Formation of coal dates back to millions of years ago, when the earth was covered with only vast moist forests having huge trees, shrubs, ferns, and etc. These plants underwent their life cycles, withered away, eventually falling back to the ground, much of which were swamps. New plants replaced them, they went under a life cycle, and the whole process continued repeatedly over the years, as a result of which the earth bed started accumulating all these dead plants. This gave rise to a very thick of layer of decomposed matters packing down plant matter, which washing away all the decayed matter. Physical and chemical changes took place as a result of heat and temperature extracting out all oxygen, leaving the plant layers with carbon-rich content, thus resulting in the formation of coal over a period of time. Here are the types of coal. Coal is a readily combustible rock containing more than 50% by weight of carbon. Coal formed can be of three types depending on the amount of oxygen, carbon, and hydrogen they contain. They are lignite, bituminous, and anthracite. Lignite is a soft brownish coal showing traces of plant structures intermediate between bituminous coal and peat. Bituminous coal or black coal is a type of coal containing a tar-like substance called bitumen or asphalt. Its coloration can be black or sometimes dark brown. Often, there are well-defined bands of bright and dull materials within the seams. It is typically hard but friable. Anthracite, also known as hard coal, black coal, etc., is a hard compact variety of coal that is a submetallic cluster. It has the lightest carbon content, the fewest impurities, and the highest energy density of all types of coal, and is highest ranking of coals. Petroleum is a fossil fuel that naturally occurs in the liquid form created by the decomposition of organic matter beneath the surface of the earth millions of years ago. These fossil fuels are then refined into usable substances such as petrol, kerosene, and etc. It is formed by the combination of hydrocarbons and other substances, mainly sulfur. When the first collected in its natural form, it is termed as crude oil. This substance is generally characterized by a brownish-black color, although it can also differ between red to pale, yellow, or even colorless. Its thickness varies from nearly solid tar-like consistency to low viscosity, almost like water. Products of petroleum. Petroleum products are obtained as a result of refining crude oil in oil refineries. There are numerous products that are created from petroleum and its byproducts. A study reveals that byproducts of petroleum alone provide scope to obtain 6,000 plus new products to name. A few fertilizers, perfumes, flooring, insecticides, soaps, vitamins, petroleum jelly, and etc. A few of the products obtained from petroleum are gasoline, diesel oil, kerosene, tar, heavy fuel oil, petroleum coke, lubricants, special naphthas, paraffin wax, and aviation gasoline. Uses of petroleum. Petroleum is one of the most important and widely used fuels in today's time. Some of its advantages are: these are transportation fuels via air, water, or land. Diesel is used to power turbines for the production of electricity in large-scale industry. Oil is used to produce electricity at homes and shops. Oils help lubricate different types of high-end machines used in different industries, hospitals, etc. Kerosene is used for domestic purpose at home. Used by chemical industries to produce plastics, dyes, paints, synthetic rubbers, pesticides, perfumes, and etc. Thank you.
Hi everyone, I'm Marc Dalangin, and in this video, we're going to talk about mineralogy, the origin and occurrence. So let's get started. Mineralogy is the branch of geology concerned with the study of minerals. What are minerals anyway? Well, in the simplest sense of the term, minerals are the building blocks of rocks. Take a look at this rock. This is a piece of the igneous rock called granite. If you look carefully at this chunk of granite, you'll see all sorts of speckles of gray and white and black. And if you zoom in, you'll see that these are actually crystals, mineral crystals. This particular piece of granite has the mineral quartz, biotite mica, and plagioclase feldspar. So on Earth, there are over 2,000 varieties of minerals, some of which are seen here. As you can tell, they come in a wide variety of colors, shapes, sizes, textures, and all sorts of different physical characteristics. But what exactly makes a mineral a mineral? To be considered a mineral, the substance must meet 5 criteria. First, it must exist as solid normal condition on Earth. Number 2, it must be naturally occurring on Earth, basically not man-made. Number 3, it must be inorganic, meaning not living or made from living things. Number 4, the substance must have a fixed chemical formula, made of specific elements. For example, quartz. It is composed of silicon and oxygen bonded together. And finally, the atoms that make up the substance must be arranged in an orderly structure. Let's make a quick recap before we proceed to our last topic. First thing we talked about was how minerals are the building blocks of rocks. And second, to be considered a mineral, it must meet our 5 criteria. It must be a solid, it must be naturally occurring, it must be inorganic, it must have a specific composition, and finally, it must have a definite structure. So earlier ago, we looked at the basic requirements that minerals must meet to be classified as minerals. But how minerals are even formed? Keep in mind that most of minerals are found within rocks. So many minerals are formed when those rocks are formed. Minerals can be formed in few main ways: sublimation from volcanic gases, crystallization of lava or magma, and deposition or evaporation from aqueous solutions. Sublimation is the process of going from a gas directly to a solid. When volcanoes erupt, lots of gases are released. The contrast between the temperature of extremely hot volcano and the much cooler atmosphere means that some of those gases are formed lower energy solids pretty quickly without even passing through the liquid phase. Since sulfur dioxide is released during eruptions, native sulfur is common to find around volcanoes. Cooling of magma or lava results in crystals and igneous rocks being formed. Different minerals are formed at different temperatures of this cooling process. Another way they can form is after a hot water flows between rocks and dissolved particles. Then, when this water cools, these dissolved particles return to a solid state and can deposit or precipitate back out. Evaporation can also lead to minerals being formed. If seawater has a large salt content, not necessarily just sodium chloride but any salt, when that seawater evaporates, it can leave behind those materials as they settle to the bottom. Rock gypsum can be formed by this process, and it is usually occurs in water basins where there's less water coming into the system that is being evaporated. Some minerals won't always remain the same mineral. A mineral can change form, or what we call morph, and can be replaced by another mineral based on environmental conditions. Since minerals form from crystallization, sometimes crystals can grow abnormally. Errors in a mineral's growth because of environmental conditions can result in twinning, the symmetrical growth of two crystals from similar lattice points. The way a mineral twins can help to identify it, since different minerals have different twinning patterns. There are two main types: contact and penetration. Contact twins involve the twinning crystals sharing only one plane between them. It looks like they're just touching each other. Penetration twins involve one of the crystals going through the other one. In other words, more than one plane is shared. Those are some ways minerals form and processes that go along with mineral formation. Thank you for listening.